So it seems self-explanatory, but like, whereas when you go to a doctor, somebody diagnoses your specific problems of one person, public health scientists look at a whole population of people and we say, we try to think about what are the problems in that population, the health issues, and then what are the underlying causes and factors. So other than researching those, then like in the general overview, people then design interventions to kind of target those specific problems. Like say, if you're looking at heart disease, maybe you would try and design a program that educated people about eating foods that were low in cholesterol so that they get less heart disease. And then you would evaluate what you did and try and see, did this work? Are less people getting sick or not? And if it didn't work, we need to do something else. And sort of how I have these three things here, these are actually, although I'm giving you a big overview, I want you to consider these more kind of like stars in a constellation of public health possibilities because there's a million different aspects of this field. People do everything from environmental to mental health to, there's a whole lot of stuff. So another point I'll make here is that what you end up researching and kind of the path you follow, it may not even exist yet, so you'll start on more of like a linear path, and then as you go, you'll see like what can I contribute to the field, how can I push it to the next point. So I'll start kind of how I got into research in the first place. Probably most of you are already interested since you're here in the research class. But how I got interested, I got an internship at SUNY Stony Brook, right down the road from you guys, and I was looking at developing different tests to measure how organisms in the environment are exposed to environmental contaminants. So you have like a manufacturing process or something, and people dump like chemicals in the river, and then different organisms don't develop correctly, or maybe it's dangerous to us in some scenarios, depending. So what we did was we had these little fish up here, the Medaka fish, and I looked at their embryos and dosed them. So down here are like the type of chemical contaminants you'd find from industries in the environment. And we had this test where this fluorescent marker molecule, in the presence of one of these chemicals that are bad, we would chop off one of the ethyl groups and make a fluorescent product. So basically we'd stick the embryo in something with a chemical and then try and measure how much of an effect it had by looking at the gallbladder. And so this is without any of the test in it, or without any of the chemical in it in the environment, and then in the presence of the chemical it lights up so you can tell that it was exposed. So the most important thing here is not only did I really like doing research, which is kind of has an ebb and flow of being really intense and frustrating trying to figure out a problem, and then kind of having more downtime. I also found that my mentor there, she kind of invited us over for dinner one day, and I was with a whole bunch of other people from the lab group, and I originally thought being a scientist or engineer, you're kind of weird or awkward, and I didn't know what to expect. I didn't think I was going to do this for a living. I was just getting this on my resume, and then I was going to go do something else. And then I was kind of sitting in her house looking around, and her family was really cool, and I was like, this could be my life. I could see myself doing this. This is pretty cool. So I kind of decided that's the way that I would go. And I've been there since, so it's worked out. So one of the other things I did, after that research internship, I liked it so much I applied for another one. This was through research experience for undergraduates, which is something you can apply to, no matter what school you're at. A lot of different schools have different ones, but the subject matter usually is school specific. So I applied to one in Brazil, a biochemistry project, and I was researching different chemical molecules that organisms produce in response to predators. So I was looking at this specific type of daddy long legs. You guys know what that is. It looks like a spider. It's a little creepy crawly. So in the presence of a predator, it'll produce these chemical molecules, and you can measure them, and it marks the stress response of the organism. So although that was sort of a little bit of a different than what I ended up doing in my career, while I was there I did a lot of traveling, and I saw this is a favela outside of Rio de Janeiro, Brazil, and I noticed in the favela a lot of people didn't have access to a centralized water system. They had these kind of tanks on their roof. You could see kind of the blue containers, and there were a lot of other different engineering abnormalities compared to here. You'd see different people's electrical equipment plugged into different poles and stuff, or somebody's stairs going from somebody's apartment down there up to one across the street. So I saw a lot of really different things and started thinking more about how the things that engineers build affect our health, and that's kind of what'll be the basis for the rest of my research. I started looking more at engineered systems, and when I was a graduate student I went to Nicaragua to look at water quality and food security, and kind of started to see how a lot of these things are related. How healthy you are is not only determined by how clean the water is you drink, but also by what you eat and the farming system that's in place and what kind of health care you're getting. There's a lot of different things, and public health and probably most of the fields you guys will look at have a lot of different aspects. So if you don't like one aspect, there's always lots of other stuff for you to look at. I continued along the same lines. I did my master's work in Dar es Salaam, Tanzania, and I was looking at, people have wells there in a lot of different places. So when in your house, when you turn on the tap or you turn on the shower, like clean water comes out. And you kind of don't think about what happens before it got there, but actually a lot of sophisticated engineering went into bringing you that glass of water. So here that's not the case, and people have these shallow wells where you just dig a hole and there's water, because the groundwater is shallow. And I compared kind of the contaminants that were present in these compared to like a closed well over here that's deeper in the ground. And we found like a lot of contaminants, unfortunately. A lot of bacteria were in the wells, and that kind of got me thinking of, what different factors go into people getting sick. And this is something that I've followed through with my research, which brings me to what I'm doing at Drexel. So some of the stuff I saw here, like you have a drinking water well here, and this is an open sewage stream, like in the background. It was really gross. And we're lucky we don't have a lot of that here, but in a lot of other areas there are. And sort of what happens between when you engineer something, even if we do get clean water, maybe it sits on somebody's porch. Maybe the distribution system that brings it from the plant to you guys isn't working right. So sometimes things happen that make engineered systems not work as good as they're supposed to work, and that's where I come in. So I did an internship at the Environmental Protection Agency, which is the U.S. government agency that protects human health and the environment. They regulate like the presence of different chemicals that industries can dump, and also are just generally responsible for clean air, water, and soil in this country. So what I did there is I just realized that I wanted to have a better quantitative background, and that sort of, I didn't have that as much from public health. I wanted an engineering skill set. So this is sort of like, if you start out as an engineer, it's probably easier if you end up being on that route, but I didn't get there as a high school student, so I ended up coming back later. I had to take classes, I had to go back, I was like sitting in, I was like 26, sitting in Calc 2 with some undergrads, and it was fine, but obviously there's faster ways to get there. But what I do now at Drexel is I'm working on different types of water systems and looking at ways that we can make them better to protect people from exposure to contaminants. So, I don't know, are you guys familiar with water systems? I know there's a sewage, somebody's sewage? Yeah? Okay, well it's really important. So, you turn on the tap, you're in your house over here, and out comes the clean water. So before it went there, what we call the source water started with something like a river or a lake or something like that. So the water engineers built this whole system that takes water out. We bring it to a coagulation basin, which is just like a big tank. We add chemicals to it that makes the dirt stick together and then settle out onto the bottom. And then on the top you have cleaner water that you take out and go to the next process. So usually that next process is going through a filter. I don't know if you guys have seen a filter before, like on an air conditioner, so it takes out stuff that's in the solution or in the air. So once you filter the water, then it goes to the filter and we have some cleaner water down there. And then we add typically a disinfectant like chlorine. So you clean your kitchen counter with bleach sometimes, or maybe you use it on your clothes, get out a stain. It's the same exact compound that's in your water system. Engineers add a really small amount that's enough to kill the bacteria and stuff that can hurt you, but not actually harm you. So obviously you don't want to, drink something like bleach or something, it would hurt you. But how much of that bleach we add is a more complicated issue because it can form byproducts in the water with different other chemicals that are present. So how we decide how much things to add, it's also expensive. That's sort of where I come in. And like here's an example of a paper we published where we tried to determine how much treatment do you need so that you're meeting the requirements you need to make people safe, but then also not going overboard where you're wasting things. So that's sort of how that works. And where I'm bringing this to the next part in my dissertation research, which is when you get a PhD, you're not just working on someone else's research, you're planning your own project and then executing that project from start to finish, and that's why it takes a while. So I'm looking, since there's water scarcity now globally, in some areas of the US even, we don't have a lot of fresh water, and that's a big problem. So in the Northeast, we have sort of the opposite problem. We have enough fresh water, but we produce a lot of storm water, which is during Hurricane Sandy, you saw pictures of flooding in New York City, and maybe some of you even had to deal with some of that. So happens when rainwater hits surfaces and then runs off and causes like floodwaters to happen, and those have a lot of contaminants in them because they come over all the city surfaces. Like, when you're walking outside, you see on the sidewalk there's all this nasty stuff, like all that ends up in that water. So one of the ways that engineers have come up with to deal with some of these issues is to reuse water, to take water that's not necessarily like at a drinking water level, but a couple levels below, and use it for other purposes that aren't drinking, like irrigating a golf course or flushing a toilet. So this is an example system. This is a system from LA, and the purple pipes are hooked up in a lot of people's houses. So they'll have two sets of pipes in their house. One is purple that carries the lesser quality water, and the other is a regular quality water that they drink. So that's one way to address the water scarcity. And so a place that has a lot of droughts and a lot of water scarcity is Australia, which is where I'm doing my next part of my work. And that is through the Fulbright Fellowship that Mr. Kurtz, almost basically Dr. Kurtz mentioned. So what happens in those types of systems, so people have droughts, so they need to conserve water. It's like a precious resource in a lot of areas, especially in this city that I'm going to in Australia, Brisbane, which is in eastern Australia. And, so if this is your house over here, you have like a roof that's sloped and rainwater falls on your roof and then goes down a gutter, like on the side of your house, into a barrel like this. It looks like that barrel on the right. And people can then use that water to do other stuff besides drink it, although some people do drink it. You can, wash your clothes or flush toilets or do any one of the household uses of it. So what we're looking at, I'm going to be measuring bacteria in these systems all around Australia and then kind of figuring out if people need to treat it more than they currently are for the uses that they are using. And also trying to figure out, like, how does this correlate with some of the weather factors, like sunlight and temperature and things that we would want to know to give people guidance about how to protect themselves from disease-causing microbes or pathogens. So that concludes part one. So I'm going to pause. If any of you have any questions about the water stuff that I'm doing, you can feel free. And or afterwards, you can ask me too. The second part of this is more like specific college advice for you guys. So I hope that I know some of you have gotten into college, so congratulations. And some of the rest of you, are y'all seniors or some juniors maybe?
Mostly juniors, yeah.
Okay, all right. So you're really in it right now.
There's how many seniors? Four seniors?
All right, juniors and seniors. So you guys are preparing. So I polled 44 high school students in the area, and I asked them what they were worried about college. So I just wanted to reassure you that if you are freaking out about something on this list, that you're not alone. There's others that are as well, and it's pretty common. So I also I asked people, have you decided on a major that you want to pursue or not? And most people were just leaning in a direction, but hadn't really formalized what they want to do yet. And a couple others had, but so I was in this blue box. I was undecided. I sort of didn't know what to do. I knew I loved biology, and Mr. Kurtz was an excellent biology teacher. He's kind of set me along this path to do this, so I'm very thankful. And there's other things that you'll have to worry about besides major, but that's something that you can start to think about, and you can ask other people kind of besides me, like what their career path is and if they like it and kind of how they got there. And I think listening to some of those stories is going to help you. So I'm going to give you some advice on some of these other points. The first is a couple thoughts on the admission process. So I know a lot of people are worried about getting into college, and it's certainly a very stressful process for sure. But one of the pervasive myths in science, technology, engineering, math, STEM fields is that you have to be like some sort of brilliant person to do this. Like you have to be Sheldon Cooper or Albert Einstein or somebody. And that's really not true. So although intelligence is one aspect of how you'll perform as a researcher, probably your perseverance and your creativity are number one, and two. So, you need to stick with problems, and like when things don't work, like tinker with it and see what else, could potentially work. And that's not necessarily like a mark of your intelligence specifically, but more can you stick with the problem and kind of, have the like passion about it to really figure it out and kind of be curious enough to see what the next step is going to be. So that, you don't have to worry, and nobody's born into this cast of like math and science superhumans. You work a little bit every year, you work a little every day, and eventually, you're going to know more than you do now. So the other thing I want to address, I think college admissions in general are just different than when I applied to school. When I was applying to college, they wanted people to be like the track star, the captain of the debate team, like a well-rounded everything. And I think you're not going to necessarily, they're not looking for that now. They want like a well-rounded class in general comprised of people who are passionate about specific things. So I think that's liberating in a way, because you don't have to worry about being like this superhuman. You can just focus on what you like and focus on doing it well and conveying that to somebody, and I think that's more than enough. So, my other most important piece of advice starts with a little analogy. So, does anybody know how you win the Hunger Games? How do you win? Besides killing everyone.
Find supportive mentors.
Okay, so
Live
you
long and prosper.
need allies. You need allies to win the Hunger Games.
Star Trek.
So not just killing other people. Yeah. You need you're gonna need people. You're not gonna be good at everything. You're not gonna be good at every aspect of the science that you're looking at. Maybe some people are better coders. Some people are better just at problem solving with physical systems. So you're gonna pair with other people, and you're gonna study together. And like the best thing that you could do is to like make friends, honestly, and just get through it together. Because if you study alone, you're gonna be sad, and it's gonna be harder. So that's and finding supportive mentors, not just professors, but also administrators, just people around your school and around you and your family that can help you through some of the tough times, like when you need it. I think that's really important for getting through some of the tougher courses and the tougher times that you'll have in college. So like, for example, and like kind of be assertive if you have, a specific vision in mind for where you want to go. Like at Hopkins, like I had an amazing experience there, but I did my first academic advisor, failed my first chemistry test hard, got like a 20, it was bad. I talked to my academic advisor, and she was like, well, you're not very good at chemistry, like maybe you should switch majors. And I said, thanks, but I think I'll switch advisors. So, so like at that point, maybe that was like not the best way to say it, but I think if you know that you want to do something, just because you fail in one little, one step doesn't mean you have to give up your whole vision. Just, change gears. Like if you're studying some way and you're failing something, like obviously that method isn't working, so just switch it up. And you have resources at your college, I think, to help you do that. Like there's entire, staff devoted to helping kids budget their time. So find out who those people are and try and talk to them, I guess is my point. And then a simple thing, but you would be surprised how many people don't, but you have to show up to class. And you have to show up to things in general. Like physically show up, don't, just go online. And I think when you join clubs and things, like it makes a big difference when you make the effort to be there in person. So I think that's something also important. Like when there's an extra help session, like just, go to it, even if you don't need it, just show up. Showing up is half the battle. So. When you go to study for science exams and things like that, maybe in high school you can get away with like just reading a passage in the textbook and being like, okay, I basically get it, I sort of know it, so I'm just going to figure it out. It'll be fine. You have to actually sit down and do the problems and noodle through it, and you'll get through it, but you can't read about science, you have to do science. And one of the ways, the things that'll definitely help you, especially in engineering, is if you pay attention to units, like meters per second squared, things like that. If you get something, if they ask you for a pressure and you got the answer in meters, like that's not right. So then you need to multiply or divide or do something else, and sometimes it'll get you out of the jam on an exam if you need to, if you just know your units and keep good track. When you go to prioritize your time, which is a huge issue in college because you're going to be there, in class for maybe 9-10 hours a week, whereas, when you're now in high school, every minute of your day is planned out. So you're not going to have that. You're not going to have your parents telling you like, oh, you got to do this. You got to, eat salad for lunch and not pizza, or like no ice cream for breakfast type of thing. So if you make a time budget and you just say like, 2 hours for exercise, 2 hours for studying, and kind of are just aware of the accounting of your time, I think that's going to be helpful for you. Especially now you have like, if you have Gmail, like I have Gmail. So like you have a Google Calendar, you can put things on there, and it'll even send you a little reminder and say, hey, you're supposed to be studying for chemistry right now, and you say, okay. Okay, so I guess have any of you worked in a lab before? Great, okay. We got one. So you'll probably want to work, if you're interested in research, you'll want to try and get some experience in a lab. And to do that, you're going to have to talk to a professor. And that person probably has a lot more experience than you, and that's fine. So I think the best strategy for approaching a professor is to be a little humble. You know, go into their lab, they don't expect you to know everything about their research. They've been doing it probably for 20 years or whatever, and you couldn't possibly be expected to know everything about their field, but you can go in with the attitude of, hey, I want to learn, you know, I'm really interested in what you're doing, and I've prepared, most importantly, by reading some of your papers, and I know, like, the gist of what you're doing. Can you tell me more about it? And, you know, not asking right away, like, I want an internship, and how much are you going to pay me to do that? Like, people generally don't respond well to that. And that applies if you're in high school, too. You can ask professors if you could even shadow somebody as a high school student, like one of their PhD students, or, you know, just learn a little bit about their lab. It's something. So I think just be prepared to answer the question, why do you want to work in this lab? So I get to, somebody sits next to me in my office and interviews undergrads all the time, and I can't believe how many are stumped by that question, why do you want to work in this lab? It's like, why do you want to be here? And they're like, what? So just think of something to say for that. And, you know, use your network. So the time to start building your network is not when you're 25 or like when you're graduating and looking for a job. It's like right now. So when you talk to a professor, maybe they don't have a position for you in the lab, but they know somebody who does down the hall that works in a similar field, and maybe you'll just go work for them. You know, this is word of mouth. Even more so, like the internet's important. You're gonna search for stuff and find it, but when it comes to opportunities, like you're gonna have to do some like people work. Oh, and you can apply for internships for your summers. That will give you funding to be in the lab, like the research experience for undergraduates, RU, that I talked about. Because when you go to approach a professor, say you've already gotten a grant for a research like fellowship in the summer, and you have all this, you know, you have some money, and you say, hey, can I work in your lab? I'm already paid for, and I mean, it's kind of a no-brainer at that point. So then you have your choice of labs, rather than trying to convince somebody to take you. So I went through some of these. This is like my little, I did all of these things, so that's why I'm listing them for you, so you don't do them. But I think some of the most important things are using the times effectively in between classes. So say you have a 1 hour period, don't just like hang around, like use that 1 hour to the best of your ability and do something. And also go over your mistakes when you make a mistake in your science classes. Like you're gonna make it again if you don't do that, and it's just not, it's not necessary to do that, you can fix it. And you're gonna have a lot of unassigned homework sets like that don't get graded, but those are very important to do because if you, like the test is going to be based on those, so if you don't keep up with the ungraded ones, then you're going to struggle a little bit on the exam. Let's skip this part. Okay. The last piece of advice I have to give to you is you have to learn to code. So I guess has anyone started to learn a little bit? Okay, a couple of you, that's great. So I was definitely slow in getting on board with the coding, and it's not like there's one specific language you need to learn or anything like that, but just understanding the logic of it and how object-based languages work will bring you, it'll give you a definite advantage when you start a science career, because every single field of science, not just engineering, you have to analyze data. And more now that we have more technology, it produces higher volumes of data, so you can't just put it in Excel, you gotta, you know, import it into some other program, look at it, so that's really going to help you. And if you haven't done that before, you know, you may not have time to learn in high school because there's so much stuff for you to learn in high school that there's just, you know, you can't expect to learn everything that you're going to need here in your toolkit. So if you do some of these websites on your own, Codegear, Coursera, the Khan Academy, they all have really great like things that you can just work through by yourself, because it's sort of one of those things you have to play around with it. It's not like somebody, you know, you don't learn coding by like, you know, somebody typing on a board and you're like, okay, you know. You have to kind of learn how it works. So that would be my advice. And if you're a high school student applying for funding in college, or a college student applying for like big scholarship money and things like that, there's a lot of resources out there for you if you search for some of them. The Drexel website has a really nice database that you can use. I think I've searched it in a couple now, and I think this one is particularly well set up because you can choose like undergraduate, or, you know, say you want to study biology, you would select that option, then it just brings up everything that applies to you. So I think that'll be valuable to you, and there's a 1 year time lag on most of these things, so if you want funding for your junior year of college, you have to apply before fall of your sophomore year. It's kind of like applying to college to get money. Yeah, so I think I think that's basically everything that I wanted to say. I'm leaving you with this nice picture of Bill Nye the Science Guy. I hope you guys know who that is. Yeah? A little bit? Okay. So he was my graduation speaker at Johns Hopkins, and he gave us some nice advice during his speech, which was to reach for the higher hanging fruit. So, you know, you have an apple tree and like a bunch of apples fall on the ground, people will pick them up and they're easy to pick up, but the really good fruit is like up there on the high branches, so you're gonna have to stretch and try and get that higher hanging fruit. So you can there's a lot of different problems that we face today as a society in science, and that science and technology and engineering and math can help to fix. You know, we have water shortages, we have energy problems, we have international conflicts. Like, there's no shortage of things that you can use this toolkit of skills to work on, so you know, I recommend that you do that and try and do something that matters.
Questions?
Yeah, ask questions. Yes.
Well, you said you were doing like chemistry as a freshman, and you basically like followed a pretty concrete path.
Mm-hmm.
So how important do you think that is to do that, to start on like a definitive path as soon as you get to college?
It depends if you have a vision for something specific or not. So if you know a general subject area that you want to pursue, but you don't, like, you know, say that you knew right away, like, I'm going to work on water systems in Africa. Like, maybe you could just go straight to doing that, and you could kind of make your own path and customize it to fit that. But if you just know, you know, I want to work on biology and I'm not sure what, it helps to start along like a tried and true path, and then as you get your bearings on that path, I think you'll start to realize what opportunities there are to extend the field, not just, you know, go along it in kind of like a path that other people have taken, but to add your perspective and your work to it. So I think it's just a guideline, like a track for you to start down to push you in the right direction, and then you'll, you know, go off and flap your wings. And does that help? Does that confuse you?
Yes.
Okay. All right. Who else? You can ask questions about the, you know, applying. Yeah.
What do you mean by coding?
Coding. So in order to analyze data, there are different systems set up in computers that you can look at trends in data. It's all about finding patterns in when you have like a lot of different numbers. So say I look at high school students and I want to know what factors affect your GPA, and I talk to everybody and I measure everything about you, like, so you have brown hair, you live in Commack, you know, and I have all this information about everybody, and I want to know what factor. Sometimes it's hard from looking at all that information just to look at it and see, okay, the factor that affects that most is how many hours you study. So in order to get through all that data and figure out what's important, sometimes, you know, you need a more sophisticated like formula to look at it. So coding helps you do that by like importing data into a structure that you can then figure out what's going on with different like math formulas and stuff. But for you to do it in Excel or something like that, you know, where you have to like, you would have to copy and paste things into different cells and anything, well, it just takes a big glob of data and it'll do things automatically for you by telling it, add